gaseous state. Introduction. Introduction to the gaseous state. There are the three states of matter, namely solid, liquid, and gas. So myself, Dr. Mr. Matkari SS from SMP College, Moro, and I am here to present the gaseous state. Introduction for this one. Gaseous state is one of the important state of matter. Basically, there are three states of matter, namely solid, liquid, and gas. The gaseous state is characterized by the simplicity and uniformity of in behavior. The gases has neither a definite shape nor a definite volume. That is nothing but they doesn't possess any shape or volume. It has low density but slight viscosity. The density of the gas is very low and the viscosity is very small. The gas distribute themselves uniformly throughout the container uh, or the available space. That is nothing but they doesn't possess any volume and they will be get distributed among the container. The volume of the gas is affected by change in the external conditions like temperature and pressure. So, varying in the temperature or the pressure of the particular system, the change in the volume will take place. The volume of the gas is considerably affected by these two external conditions. The ideal gas obeys the ideal gas law like Boyle's law, Charles' law, Graham's law of diffusion, Avogadro's law at all temperature and pressure, while the real gas or non-ideal gas obey the gas law at relatively low temperature or high temperature and a low pressure. Thus, the ideal and non-ideal gases differ in many ways or in many aspects as like this. So here is the distinguishing points between the ideal and non-ideal gases. So ideal gas, here first one, ideal gas obey the gas laws at all temperature and pressures, whereas the non-ideal gases does not obey the gas law at all temperatures and pressure. Ideal gas obey the ideal gas equation PV is equal to nRT under all conditions. That is nothing but here P stands for pressure, V stands for volume, which is nearly equal to the N number of moles of the gas, R is the gas constant, and T the temperature in Kelvin. Non-ideal gas is nothing, does not obey the all ideal gas equation. PV is equal to nRT under all conditions. The volume occupied by the gas molecule is negligible in comparison with the total volume of the gas. Here, in this case, volume occupied by the molecule cannot be neglected in comparison with the total volume of the gas. Next one, for ideal gas, in this case, the intermolecular attraction is negligible, whereas for non-ideal gas, the intermolecular force of attraction cannot be neglected. Boyle's law. In 1662, Robert Boyle has given his statement related to the compressibility of air, and the statement of the compressibility of the air has been given by Robert Boyle, and this law is known as the Boyle's law. Statement for this particular law: for a given mass of a gas, the pressure is inversely proportional to its volume if the temperature is held constant. That is nothing but at constant temperature, the pressure of the gas is inversely proportional to its volume. So vice versa, when we can increase the pressure, the volume will be decreased for the gas at constant temperature. Mathematically, this can be given as P is inversely proportional to V at constant temperature. So temperature must be kept constant for this particular. So this can be written as P is proportional to R by V at R is the gas constant. PV is equal to R, which can be written in the form of PV is equal to R. For an isothermal process in which the initial values P1, V1 are changed to the values P2 and V2 and can be written as P1, V1 is equal to P2, V2 at constant temperature. When we can study the isothermal, that is nothing but by keeping the temperature of the system as constant, one can have the equation P1 V1 is equal to P2 V2. That is nothing but under these conditions, one can have the pressure of the first state and volume of the first state is directly